Hello and welcome to another video of Advent of Code using jakt. We're on day 13 now, which should load. Now, just before I do day 13, I just wanted to show something that I found out. Basically, every time you refresh the browser, it will change what the map kind of looks like, and you can kind of see there's a fixed river, and that's the bridge that we crossed at some point. Maybe this is the path that we have taken, but like kind of the foresty area, I guess, changes every refresh. Unfortunately, in Ladybird, it caches it too heavy, so you can't actually just refresh, you have to also bust the cache. But anyway, into new day 13, so we can do that. Now I have a feeling, yeah, this input is the input. So what I'm going to do is what I've done in the past, and just go to adventofcode.com and get it from my host computer. So down to there, and in Advent, indeed, and put in that, and go back here, and I guess I kind of want to do that so the font's not blurred. Control Shift N. Yeah, actually I could probably just go SSH this thing, and yeah, won't know how to do that, and I can trick it into doing that, and then I can go into Advent of Code and run that and get the example code. And I've done that thing again where I've saved it to the input, not the output. So I want to move outputs day 13.example to input, day 13.example, and then I want to can't think of it off the top of my head. I wanted to select the second to last, or the second thing from the last command, but that's that. Right, and somewhere here there should be a 13 an answer. So we can go part 1, 13. And so now if we go test 13, we can compile that thing, so it's created a day 13, which we can get to. So it basically defaults to the cat, so they'll both fail, and that's our actual input that is downloaded. So what do we want to do on this? Right, we're climbing a hill, and yeah, we use some search algorithms to find the path to the top of the mountain hill thing, and now we want to use the fact that we're required to contact the elves using our device that we fix somehow. So it's still not working though, the device that we have, so we need to reorder the packets somehow. So the packets are this, I guess, and yeah. So the packets are split by a blank line, that's cool. So we need to identify how many pairs of packets are in the right order. So I guess there's some way to tell if they're in the right order or not the right order. So packet data consists of lists and integers. Yes, I see. So it can sometimes just be an integer, or it can sometimes be a list of integers. And this is like a list of. Yep. And 0 more. Cool. Each packet is always a list and appears on its own line. So this is one packet, this is two, this is one packet. Alright, so we're always getting two packets, so two packets, two packets, two packets, two packets, and of those pairs we need to work out whether that's the right order and that's the right order and that's the right order, but we don't care about like that and that. And each packet is always a list, so we can at least have just an empty list. I wonder if in jakt we have a just parse a list output, because I think the debug output kind of prints similar to that if we have a list. We could try this. We could go let a equals 1, 2, 3, I guess, and then print line and a, and do that, and we'll just tack on example there. So we'll still print our example input, but it will hopefully, I should have put it at the bottom, but because it's like a little test thing. So yeah, it printed out this 1, 2, 3 in that order. So it like has spaces around it, but it's very similar to what it would be. And I wonder if we can do something like that. I'm not sure. I'm not sure jakt likes that. We can't have like an array of differing types. So that could be a problem in itself, actually, because we need some way to kind of store this. So I'm thinking could have an enum type thing, and it's like either a list or it's a integer, and we have an array of whatever that enum type is. And in the jakt enums, you can have like have like a value attached to the enum. So we could probably have a list. In fact, like I'll write it out after getting rid of those spaces. Enum. So this can be like a packet data, I guess, and what it could have is it could have int, and this can have an I64, or it could be a list, and this can have I guess L, and it's going to be an array of 64, like that, and we can probably have a parse function on it as well, and we will probably have a struct, because yeah, there's some benefits to struct and class. I think if you want to have copy by reference, you would always use class, but I think for most things struct is probably better, and it's like quicker to prototype. Don't need to worry about like private and everything, and we can like, yeah, it's got benefits. So our packet is going to have, I guess it's just going to be a packet data, so something is going to be that. I kind of want to get in there. I wonder if we can do that. Just need to find out the keyboard shortcuts, and it's nice that it's intuitive. So this can be our data, and it can just be our packet data. And so I guess we will want that function, function parse, and this can take in a non-string, and it can return packet data and do that, and there will be like a recursive type thing, because it's really a list of packet datas, packet data, and individual packet data could be in it. So that will be kind of recursive, and I think I wanted to kind of abstract that away and have it pass a non-S string, and this can just return a packet. And what it will do is just return packet, and data can be packets, data parse, and just pass that string there. And like, I guess, yeah, that looks good. So like each pair of lines, so I wonder if we can kind of do that. I think we need to do something like for I in 0 ... Yeah, well, I think we need to save our lines. Well, no, we can have like a mute packets equals that, and I guess it's going to have a type of packet. And we could kind of assume that it's that, but I think what we'll do is if line equal dot length for a string, if it is empty, then we do something with packets, and then we set packets back to that. Otherwise, we that one, thanks. And otherwise we will packets.push and packet pass of whatever this line is, and it's anonymous, so we can just do that. So that's that. And like, what are we even trying to get? I won't bother what it's actually printing out. Yeah, I think I still need to read all this text, but we can print part 1 and just have that for now. So this pass function we are still not doing. So I guess we can take this. So if S, I think I want it match on s.bytes at and 0, and if it is an open bracket, we are going to do something. Otherwise, we are going to just do something else. So if we find a bracket, that means it is a list, and we want to basically take whatever current string we have and trim off the last character. So I think I've checked it before, but it didn't have an assert. It would be kind of cool to have an assert, because I kind of want to have like if s.bytes at s.length -1 not equal b of that. Maybe we can abort, and maybe we can even print line expected ending that character. Otherwise, we will get a substring, and that can be substring, and this took a start and a length, I guess, and the length will be s.length -2, because we've taken off the things, and I'll do that to get there, and the start can just be 1, so we're basically trimming off the 2 characters on the end. And so here we can just return, in fact, we could probably yield this and do like a fat arrow, and it will just, yeah, we can kind of get rid of some stuff. We do a fat arrow on that, yeah, and then I think if we do that, I kind of want to do that, I guess, and that, and then I think it all matches up. So in this case we will yield a, what do we call ourselves, packet data dot list, and I think we might need that L colon, and L can be yeah, we kind of need to split this now. Now it's kind of annoying. Yeah, I think we need to do it like kind of stack based, because I was thinking, say this string here, we want to split it by commas, but then it will get it will basically split that comma, and we will be trying to parse just open bracket then two. But really, what we want to do is find the comma that is like within this, and to do that, I think we need to actually keep track of where we are, and we can't just like recurse into it. Yeah, I guess what we could do is return a packet data and like the rest of the string, and we can, so we're at this point and we're now thinking this is a list, go to the next character and parse this entire string, which has commas in it, but what it will do is just pass the first one, and once it gets to a comma, so we would have to kind of have a match for a comma, and once we get to a comma we just return the whatever's rest in the string. So we can return a packet data and maybe it's string question mark, and here we can like yeah, maybe have it like that, and while we yeah, sub dot length is greater than 0. While that substring is not empty, and we want to have like a list, mute L, we'll just call it, and we have to type it on packet data, and we can just initialize it to nothing, and that means that this will need to throw, which means that this will need to throw because that does it. Right, so here while that string is empty, what we're going to do is actually sub, and well, we're going to let ret equal packet data parse, and this will be that sub, and it's anonymous, so that's cool. And now we can l dot push ret.0, and we can set sub to be ret.1, and I think that will be good. And maybe we'll just return an empty string. Yeah, I think we can just always return a string and it may be empty, and when it is empty this will become that, because substring will always return something. And here we can just return that, I think, because we've filled up L with everything and we've parsed just the token. And say if we are on this one, we would see that it's a list, so we'd start parsing a list. We would then start parsing this, we would see this, see it's a list, and then start passing this inside of an inner list, would see that, and then would see we haven't covered that, but we'll just parse it as a integer, and then that would then be an empty string because we wouldn't see this because we split it off here. At which point we would then be at this point, and it will add that list to the outside list, and then we'll be at this point seeing a comma, and we'll be like, that means that we need to kind of just return nothing, which doesn't quite work here because we are always expecting something. So I think what we need to do is in actually just this else case, this means that we're not in a list. I wonder if that formatting is out. It kind of just looks a bit out. So in this case we are an integer, and I think we want to scan forward until the next integer, and because we are an integer we can kind of tell it, and in this case here we're only actually looking until that end bracket, so we won't actually see this comma. So I think at this point we just want to have s dot split and have it split on a comma and get the first one and go to int on it, and say that we trust that it's an integer, and we'll convert that to a nice 64, and that will just be packet data, and this will be an int, and I is whatever we got there, and then we just want like, no, we kind of want, yeah, I think we want to get that split. We want to get that split. And do split 0, we tried that. And then just return split 1, so everything after that comma, and we can probably yield that tuple. And here we are only doing this, and because it's a list it should be the only thing, because when we like kind of get to that point, like say for example we've reached this point, the thing that we should be looking at is basically the rest of this list, which will go to, right, no, I think it could be wrong, because yeah, we see this point and this, yeah, we need to know where the end is. So say in this case we would see this, and we're kind of assuming that the end of the string will have the closing one, but then here the end of the string is actually this 4 character. We really only want to go to this point here, but we can't just search for the first closing bracket. We actually have to find the matching one, because this one, the closing bracket is actually the end of the string. So what I think we want to do is take out this and have another function end bracket, and this can be packet. I wonder if, because we're in the namespace of packet data, we can just call it find end bracket, and we'll pass it that s as well. And so this is going to be function find end bracket s, except this will be a non-s of string, and it will just return us a U size, I guess. And here we will start at 1 and go to end bracket. Yeah. I think we might want -1 there. So say for example, what's an easy one? This one. So index 0 is the opening and index 1 is the ending. So we want to have a substring from 1 to and length of 0. And so I think we want to subtract 1 off the end bracket. And say for this case, opening is on 0 and closing is on 2, and we want to go from 1 length 1, which is 2 minus 1, and say this one 0 and then 1, 2, 3, 4, 5, 6. So we would want to go from 1 length 5, which is 1, 2, 3, 4, 5. Yeah, so we just want to go end bracket -1. And then when we return, we want to return whatever's at the end, I guess, and that can be s.substring, and start will be end bracket +1, I guess, and length will be s.length minus end bracket. And yeah, so say for example this one where we will kind of have to, in the start bracket will be 0 of the string, because we'll be in a space where we're only looking up to the 4, and the end bracket is at 2, 0, 1, 2, and we will want to start the substring 1 after as well, because that comma, so we would actually want end bracket +2. And I think this is where I kind of want this to be kind of in a thing like that. So we go from 2, and then I guess we would want -3 for the length. So here we would have a string of length 1, 2, 3, 4, 5. Would have a length of 5. End bracket would be 0, 1, 2, and we're wanting to go from 3, 4. We're wanting to go for 4, but only for 1, which would be 5 minus 2, which would be 3, minus 2. Right, so I think that might be right. And maybe I'll go print line s equals that, sub equals, we can't really get sub there, and rest equals that, and we can pass in something like that. And potentially that will all just work. So maybe we'll try and compile this. It doesn't compile. It doesn't like some things. So I think I want to do 2 and all this, just so I can kind of see it go. Right, so we've got a W just randomly. right, that's because I never actually did that, and maybe we'll just return UZ and put a to comment there, because we will need to do that. Right, so we don't know about packet. Right, so that means we kind of just want to go dot zero there and ignore the rest of the string. Right, and that looks like it is compiling, and it might even show us some things, except in bracket will always be wrong. So how might we go about finding the end bracket? We get an overflow, an underflow, so we're subtracting 1. So what I think I need to do is run day 13, and that didn't say what we want, but I think we need to maybe here, yeah, and it will probably be this here, because in bracket is going to be U size, so maybe we can just set it to 1 to start with, because straight away we're trying to subtract 1 off 0, which isn't what we want. So here we're getting 1 minus 2, and that is fine because that is this down here. So I think well, in fact, I know what. Yeah, I think I just want to find the end size. So how might you do that? So this is assuming that the very first character is the very first character is a thing. So what we want is a stack type thing, I think. In fact, it might still be there. Get grep stack. Do we have, well, I guess, like our list is actually well, I think it's built-ins array. So this has a push, and it has a pop, and the pop takes it off the last element, and the push, I assume pushes, this one, it puts it at the end. That looks like it puts it at the end. So we have a push and pop for that, and I think I need to close that. So we'll have a mutable stack, and it will just be, and it will probably be a stack of U sizes, and yeah, we want to the first character we know is, and then we kind of want to just do a loop while stack dot length is size. I think a list is empty. I think this is my code base, but yeah. So open was a set. So I think a stack might have it. So while our stack is not empty, we want to basically do some things, and we probably also want to have a mute I, which is going to be a U size, and it can start at UZ. start at 1, sorry. And here we run match on s.byte at I, and if it is a not that one, that one. If it is a open bracket, we are going to. I wonder if we can just go stack.push I, and if it is a closing bracket, we are going to stack.push pop. And we are going to I++ at the end, and we will also need an else, and this can just have a nothing, and here we can just probably return I. So basically, once the stack becomes empty again, that means we found the opening, we found the closing one to our first stack. So if we run that test, and maybe the 2 and win. Right, so we need a throw because we create some things, throws, and right, so I think we kind of just need to wrap things like that. Yeah, that is what we need to do. But here we don't do. It's just a warning though, and we get a crash somewhere, but that's all right. We can work it out. So because it is a warning, I wonder if we can like just let foo equal that, and it's like inside of or maybe unused. We'll just do that, and it'll probably be fine. Yeah, so that looks like it's compiling. Here we print line s is that, and end bracket equals this, and s and end bracket. So I kind of want to. We're not allowed that. I put a quote there which I didn't want. That looks better. That looks better. So it's crashed, but that's right because I just want to run. I want to see what it reckoned. So I reckon end bracket was 11, and maybe what I will do is, and what's the thing that it's saying on index is less than, yeah, so we basically go too far, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so we kind of go 1 over, so I think we're going to go I minus 1 there, and we start at 1, but yeah, every time we kind of increment that, yeah, so I think that is what we want. Right, and we can probably like print line sub is that, yeah, you can go away as well. It still didn't like that, so yeah, I wonder if that is because it's failing somewhere down there. Print line L equals that. And I think this potentially needs to be -2 here. Oh no, it does get the sub. Cool. So that sub looks about right, and then it never prints this. So we kind of recurse in. So maybe what we can do is print line rec equals that and see how many we actually get. And I think I potentially also want it doesn't matter because it'll return what I want. So we get one, but then the return string isn't what I expect. I would expect all of that, and I think that's because our we just do a split on this. So I think what I really want is, well, we can see and what sort of type is that? That's a string. So if we look at runtime, and I think string is a built-in, no it's not, jakt string. And if we look at this and split, I guess, split limit, that is probably what we want. So split limit and limit 1, I guess. So I'll see if we're allowed to do that from Serenity. Test that to that. Couldn't find that. Right, it doesn't like it. What was the other thing that could be useful? Another thing would be like find, or like I kind of want the first character that happens to be that. I think I need to just write a function for that, or like being a size can be 0, and while I is less than s dot length, and if s dot bytes x I equals a byte of a comma, then we will break, and at which point here we can have substring, and start can be 0 and length can be I, and num, and then num, and here we would have a rest, and that is s dot substring, and start would be at I plus 1, I guess, and length will be s dot length minus I minus 1, just minus I, minus 1 as well, I think, and then here we can return rest. Right, that's not what I wanted. I wanted to go there and run this, and that's just already compiling, so do that. So I have a feeling it's probably going endless loop somewhere. So it reckons sub is that. We never I++ that. so it would never find it. I would imagine when it's down to looking at this, it won't find that eye, and it will still fail somehow. But we'll see how it goes. Right, so we are getting somewhere. So it's parsing. That all looks good, and the rest looks like that. And then here, yeah, I think if I is greater, if I like equals, yeah, s dot length, we can probably do let rest equals match on I and s dot length. We can return s dot substring. We can just return an empty string then. Otherwise, we can return this thing here. And do that. Right, so let's get back this one. Right, we are not allowed that. I wonder if we can go match s dot length, and if that is I, then do that. Oh, it didn't like that. Right, I think I just need to, if I equals that, I wonder if, that's not the one I wanted. I wonder if I can have like this sort of thing, and have it like equal. No, we're not allowed that. So the match isn't working, but yeah, I guess what we could do is, we could probably let data equal packet data int I can be num.to int as I64, and then here we can return yield data and empty string, and here we can yield data and that string. Yeah, that sounds better. Something it didn't like there. We did need that bracket. What doesn't it like here? If block is not allowed to yield values. Alright, I guess we will have a mute rest, and it is type string, and it can just be that, and if it is not that, then we will set it to be this one. And like, no, I want like that, but I just want to like go to the end. I do that and do that and do that, and run that. And now I'm hopeful that I might get some more like debugging. Cool, so it crashed, that's right. And 1 minus 2 is what it crashed on. So here we have gone back up to the list parsing thing. So we see we got like a list of ints. So we had 1, 1, 3, 1, 1, which looks about right. And then we had that error there, which means that if we kind of need to do a similar thing here, not by doing that, by actually going copy. So my keyboard, I've talked about it before. So like if I push and hold Z, so that's my Z key. If I push and hold it, it's a control. So that is why I sometimes have weird things. So if in brackets, and I wonder if I just want this to be called I, and we can just have that, and then this can be I. So if I is not the length, then we will set it to this. And I guess compare that. So here we're looking for the comma. Yeah, so I will always be a thing. So we almost need to like +1 here. And does that look a bit more right? I think this will just be minus nothing. I'm just thinking, because if I is actually I +1, then this will be I minus 1 minus 1. So it was -2. That does kind of make sense. Right, so we get our L, get that, and yep, that sounds good. And we just need to recompile that. And I think at this point we might have parsed everything. I'm hoping that we have got to the end of our errors, and we should, yeah, we've parsed everything. So what I think I'll do is get rid of these print statements. And we didn't have any there. So I think I just kind of want to, maybe I can do it as part of this and just change it later. We'll just print out packets. And that should hopefully print out all the packets that we have, except we clear them every time. So print line packets equals that and packets. And maybe this can just stay as that, because we will need to do something with the last pair as well. So maybe I'll actually do that, and have that just go back to being nothing. I'll just that nothing. And here I hope that I can kind of see the structure that it's going. Unfortunately it won't print it in a nice way, because it will kind of just default to this, but we can see that we have a packet which happens to be a list, and the list has a list of ints, so it has 1, 1, 3, 1, 1, and then that will end that packet, so that is one packet. Then the second packet has another data list, and the list is int 1, 1, 5, 1, 1, which looks right, and then that packet ends, and there's only 2 packets in that first packets, and then we do it again. And here's a bit more interesting. So we have a list, and the list has the first element being another list, which its first thing is an int of 1, and then it closes it there. And then its second element is a list with a 1, a 3, and a 4, which that doesn't look right. No, it was 2. I think I looked at the I instead of the 2. So 2, 3, 4. And then the second packet in that group should have a list, which contains a 1 and then just a 4. So that's looking good. I feel like I'm parsing it correctly. I would be like maybe a bit more comfortable if we could say print it rather than, yeah, so maybe I'll just make a quick function to string, and this can take this and can just return a string. And I guess this will just return data.toString, and here we can have a function to string, and we'll take in this and it will return a string. And I think just the way I'm going to be doing it, this will be throwing, because we basically throws, and then in here we can have kind of this, and packets 0 and packets 1, and maybe we can copy that whole line and do it again there. And this can be dot to string, and maybe I'll just copy that and click there first, and then there, and that's what I wanted to do. The mouse is being laggy again. Running inside a VM does that for you. And then, so this toString function, we can do a match on this, and if it is a int, we can get the I out, and if it is, we will just return format, and we'll format that I. And if it is a list, we will have an L, and this is where we will do something bit funny. So we will maybe create a string builder. So I think not boilerplate. Help is right. This is how we create a builder, and we will builder.append string, I believe it is, and we will just append that, and then for each thing, what do I call it? For each D, for each data point in L, we will builder.append string, and this will be d.toString. And if this is, so we need like a new first equals true, I guess, and if this is the first, we will set first equals false, I guess. Otherwise, we will go builder.append string and just append a comma. So we won't do that the first time, otherwise we'll get a comma each time. At which point we can builder.append string and do that, and then just yield yield builder.toString. So I think they'll like print it out a bit nicer, except it doesn't quite. Right, so I think I've missed a brace somewhere. Yeah, that looks like there might be a missing brace. Right, so I think I want to do that, and here's that thing where I kind of would have done this quicker in Vim, but I don't quite know how to do it optimally. Right, data.string is not found, but this data might be, not this and that. And that looks like a file. So I think what will happen here is we're now parsing the input and probably printing out the same input, but we've parsed it and reformatted it, and we kind of outline it. So this gives me more confidence that it is doing the correct thing, because I can see that it is. And this one didn't. Oh no, this one did. I was looking at the one above it on the other page, and that all looks good. So what I think I'll do here is add all of this stuff and commit this up as a 13 parsing complete, and I will leave it there for this video. Because yeah, that took a bit of time, and I think a fresher brain might be good for actually finish like reading how the rules are going to work, because we need to see whether the order is right or not. But now that we've kind of parsed it into a structure that we can use, that part will hopefully be easier.